I'm only going to be doing the questions where we have to find the values of a and b, given that the equation or the piecewise of a function is differentiable. So first thing we need to know is that, let's say f is differentiable at, let's say, x equals to a if I have two conditions. One, it is continuous. If it's continuous, what does that mean? It means that the limit when x approaches a from the positive side is equals to the limit as x approaches a from the negative side. So since we know this, what are we gonna do in the question? They told us that it's differentiable, so I'm gonna find the limit as x goes to the positive value from whatever number they told us, and I'm gonna equate it to the one where it approaches the negative one. They told me it is differentiable, so there's no way it's not gonna be equal to each other. So this is, I'm gonna find the equation and then just substitute. And if, so this, yeah, we don't really use this, but is equals to f of a, we already know that. Okay, and then if the f prime of a as it plus is equals to f prime of a minus. So the derivative at a from the right side is equals to the derivative of a from the left side. So let's try to solve a question. Okay, so we're given f of x as the piecewise function, and they're asking us to find, or if it's differentiable or not. So first thing we said, we're gonna find if it's continuous. How do we do that? We're gonna take the limit as x approaches 0 from the right side equals to the limit as x approaches 0 from the left side. Did I switch them? Okay, so right equals left. But let's check if that's true. So I'm gonna take, first of all, limit as x approaches to 0 from the right side. Which one is it? It's gonna be this one because greater than 0. So I'm gonna take 2x minus 1 and I'm gonna substitute 0 into the equation. Into 0 minus 1, which is gonna give me negative 1. Now I'm gonna find it from the left side. It's gonna be this one since it's less than. So x squared plus 2x plus 7 is gonna give me 0 squared plus 2 times 0 plus 7. This is gonna give me 7. So خلاص, from now I know, since my limits are not, the limit from the right is not equal to the limit from the left, and they're not continuous. Since it's not continuous and it's not differentiable, there's no need for me to continue. So if I want to justify my answer in the exam, I'm just gonna write limit as x approaches to 0 plus of f of x is not equals to the limit as x approaches 0 from the negative side of fx. وخلاص, that's it. That's all I need to do. So it is not differentiable because it is not continuous. So that's it. Okay, here's our second question. They're asking us to find whether it's differentiable or not. So I'm gonna do the same thing. First, I'm gonna find the limit as x approaches to 0 plus of f of x. 0 plus is gonna be what? This one, because greater than. So 2x plus tangent x. I'm gonna substitute. So I'm gonna have 2 times 0 plus tangent 0, which is gonna give me 0. Then I'm gonna find the limit as x approaches 0 minus of f of x. Minus is gonna be x squared, which is gonna give me 0 squared, which is 0. Type until now, it's justified. I have limit as x approaches to 0 minus of f of x is equals to limit as x approaches 0 plus of f of x. Now, this is the first thing. The next thing for continuity is that the limit as x approaches to 0. Where is this? Okay, so limit as x approaches to 0 should be equals to f of 0. Which one is f of 0? The one that has the equal sign. And here, see, this one is, where is it? Here, this one is greater than or equal to. So I always choose this one to substitute 0 in. I'm not gonna substitute again. Here we substitute 0, so it's gonna be 0 as well. So my answer for this one is 0. This one is 0. 0 is equals to 0, so yes, it's continuous. Now, what's my next step? I need to find if the So I have here two conditions. If it's continuous, is it continuous? Yes, we check that box. Now we need to find if f prime of 0 is equals to, going to the right. So after we check this, we're gonna move on to this step. What am I gonna do? I'm gonna make a new one. So I'm gonna do f prime of x. I'm gonna make a new piecewise function. I'm gonna derive. This is gonna be 2 plus the derivative of tangent x is secant squared x greater than or equals to 0. Sorry, this should be great. Okay. And the derivative of x squared is 2x. Now I'm gonna check f prime at, okay, so f prime 0 to the right. Which one is it gonna be? This one, because it is greater than. So 2 plus secant squared 0. And I'm gonna check it from the left, which is 2 times 0. This is gonna give me 0. This is gonna give me 3. So are they both equal to each other? Our condition said what? That these have to be equal. So f prime of 0 plus is not equals to f prime of 0 minus. So this function here, the piecewise function, is not differentiable. This one the teacher did not do it, but I'm pretty sure my answer is correct. Okay, so here they are telling us to find the values of a and b, and it is given to me that it's differentiable. So is it differentiable? Yes, it is. So it is differentiable. So that means it is continuous, and f prime of a plus is equals to f prime of a minus. Now, so which means let's start with the limit as x approaches to 0 plus of f of x is gonna be what? This one, ax plus b. I'm gonna substitute for x, so it's just gonna give me b. Now I'm gonna find the limit as x approaches to 0 minus of f of x, which is gonna be this one, x squared plus 2x. It's gonna be 0 squared plus 2 times 0, which is equals to 0. Now, they told me that it is differentiable, so that means it is continuous. If it's continuous, the limit from the right is gonna be equal to the limit from the left, so I can equate them. So, b is equals to 0. I found my value of b. Now, I need to find a, so I'm gonna do the derivative like we did before. We're gonna make a new piecewise function with the derivative. I'll do it here. F prime of x is equals to 2x plus 2, x greater than, less than 0. And here I have ax plus b is gonna be a, greater than or equals to 0. Now, I'm gonna find f prime of 0 plus. F prime of 0 plus is gonna be what? Just a. Now I'm gonna find f prime of 0 minus, which is gonna be 2x plus 2. And again, I'm gonna substitute my 0 here. Here I cannot substitute, and it's a constant. Plus 2, which is gonna give me 2. We know it's differentiable, so that means f prime of 0 from the right is equals to f prime of 0 from the left, so I can equate them. So I'm gonna get a is equals to 2. That's it.